All right, so the next session under the discrete time Markov chains that we want to consider is the state probability distributions, okay? So the state probability distribution is one way to estimate an n-step transition probabilities of a Markov chain. In other words, sometimes you may be given an n-step transition problem when you have a one-step transition probabilities. So in order to solve for this kind of problem, you can make use of the state probability distribution approach. In our next tutorial, we'll take a look at how to use a different technique called the Chapman-Kolmogorov equation to solve for the n-step transition problems, okay? So now let's take a look at the state probability distributions. So consider a Markov chain where the state space is finite. Suppose we know the probability distribution of the process at time 0, and this is shown in equation 1, okay? So this is the state probability distribution at time 0, okay, which is similar to the initial probability distribution, okay? So this is the probability that we are going to observe the process in a finite number of states at time 0, okay? So if we are to assume that the process is starting from state 1 at time 0, then the probability for this process is going to be 1, and the probability that we are going to observe the process in any of the other states will be 0. Similarly, if we are to assume that the process is starting from state 2 at time 0, then it means that the probability of observing this will be 1, and the probability that we are going to observe the process in any of the other states at time 0 will also be 0. Okay, so once you're able to establish this, then to obtain the probability distribution of the process at time 1, at time 2, in that order can be obtained using the law of total probability, okay? So let A be equivalent to the process of being in state J at time 1, and let B index I be equivalent to the process of being in state I at time 0. So then to obtain the state probability distribution at time 1 can be obtained using the expression in equation 2. So we know we can express this using the total of probability, okay? So always the future state will depend on the current state, and this will be a one-step transition probability, okay? So we can rewrite this in this form, okay? Then multiply by our initial probability distribution. So we know this is similar to that from equation 1. This is similar to that, okay, from equation 1. And this is also similar to our transition probability matrix. So that's what we have here. So to obtain the state probability distribution at time 2, we can also use the expression here, which can also be expressed using the total of probability in this form. So it must always, the future state must always depend on the current state. Okay, so we know that this is also going to be a one-step transition probability. That's what we have here, multiplied by this. And we know this is also going to be that from equation 2. So this is also going to be similar to our transition probability matrix, okay? So once you multiply through, you're going to obtain this result, okay? So we can deduce that the n-step, the state probability distribution at time n can be obtained using the expression in equation 4, okay? So we just have to know your initial probability distribution, and you can obtain the result for the others, okay? So intuitively, the state probability distribution at time n plus 1 can also be obtained using the expression in equation 5, okay? So let's quickly take an example. A mathematician is trying to create a model to analyze the creditworthiness of various companies. He decides to create a model with 3 levels. Companies will be graded as grade A, that is the highest level of creditworthiness. Grade B, that is less creditworthy but still operational, and grade D to be in default. So credit reviews take place at the end of each month. He assigns probabilities for moving between states as given in figure 1. So this is going to be the state transition diagram for the problem at hand, okay? So we want to find for a company that starts out in grade A at time 0, what is the probability that it is a grade A company 3 months later? And secondly, we want to find what is the probability that a company in grade B at time 1 is in grade B at time 3, okay? So let's take a look at the solution. So first, we estimate the transition probability matrix for the process, assuming that the states are in order. So we have grade A before grade B before grade D. So this is going to be the transition probability matrix. We have our future state and we have our current state, and we obtain this from this diagram, okay? All right. So first we want to find the probability that a company that starts out in grade A at time 0 is in grade A at time 3. So since we know that the company starts in state A, the probability of it being in state A at time 0 is going to be 1, and the probability that it is in any of the other states is going to be 0. So the row vector of probabilities is going to be in this form. So this is going to be the initial state probability distribution. Okay. So then the probability that a company that starts in grade A at time 0 is in grade A at time 3 will be equal to that. Okay, so once we take the difference in the index set, we obtain this. So this is now going to be a 3-step transition probability, but we have a 1-step transition probability. So we can use the approach of the state transition probability. That is the expression in equation 4. So once we do the expression in equation 4, we can obtain this. Okay. So we know our initial probability distribution to be that. And now we can take the cube of this transition probability matrix to obtain this. Okay, so we can use a calculator to get this. And once you multiply row by column, row by column, row by column, you're going to obtain this. Okay, so the probability that a company that starts in grade A at time 0 is in grade A at time 3 is going to be the first element in the row vector, which is 0.7498. So the probability that a company that starts in grade A at time 0 is in grade B at time 3 will be that, and is in grade C is in grade D at time 3 also will be that. Okay. All right. Now let's take a look at a second solution. So here I want to find the probability that a company that starts in grade B at time 1 is in grade B at time 3. So first we can get the initial probability distribution. Since we know that the company starts in state B or grade B, the probability of it being in grade B or state B at time 0 is going to be 1. And the probability that it's going to be in any of the other states is going to be 0. So the row vector probabilities is going to be in this form. This is going to be the initial probability distribution. That is the probability, the initial probability distribution, right? So once we have this, we can then find the probability that a company that starts in grade B at time 1 is in grade B at time 3, which can also be expressed in this form. Okay, so once we take the difference in the index set, we are going to obtain this, which is now a 2-step transition probability. So using the expression in equation 4, we can obtain this, okay, which is going to give us that. So once we use a calculator to compute the square of the transition matrix, we are going to obtain this result. Once we multiply row by column, row by column, row by column, we're going to obtain this result. So therefore, the probability that a company that starts in grade B at time 1 is in grade B at time 3 is going to be the second element in the row vector, which is 0.648, this one, okay? So the probability that a company that starts in grade B at time 1 is in grade A at time 3 is going to be that, and is in grade D at time 3 is going to be that, okay? So this will be a trial question. I will leave the solution in the description of this video so you can check it out. Please, if you find value in today's tutorial video, don't forget to subscribe if you have not, and thank you for watching.